to our kind of soft launch of a new concept we're trying out here at Instrumental called Change Notice. My name is Anna Shedletsky. I am founder and CEO of Instrumental. I'm actually joined today by Alex Lee, who I'll let introduce himself, but he's a member of the Instrumental team. But that's actually not what he's here to talk about today. Alex, do you want to give us a little bit of your background and why you're on the show today?
Yeah, sure. So I'm a sales leader, Instrumental, kind of like an old salty veteran, equipment sales in the industry. Then I was with Keyence for about 14 years, and have a lot of experience with inspection technology, microscopes, automation control technology, and in the physics background. So just been in the optics, electronics, and inspection space for a very long time, and excited and love talking about technology. So this is kind of like dream come true, to be honest, a little bit.
Awesome. Well, we were really excited to have you on for this kind of first soft launch of this cast because you've been selling computer vision solutions for a really long time. And you've sold a lot of different kinds of them to a lot of different types of people. You've seen all the different ways in which they work and maybe don't work so well. And we thought this was a great opportunity to kind of dig into that experience and maybe learn some things and teach others about what maybe your sales rep won't tell you or don't tell you when you're looking at a computer vision system. So maybe as a starting point, just to dive in, it would be great to maybe, why is this topic important to you? Why is AOI such an important piece of the puzzle for automation and kind of smart manufacturing?
Yeah, I think it's important because for a lot of reasons. Well, one, it's essential for manufacturing. I mean, you really can't to use technology to aid in able to see what you want to see, to characterize, to discover, to monitor, but it's complex, right? And it's hard to understand like what's the right thing to do. If you get it wrong, it's expensive, it can be painful, and honestly, it can haunt you for a long time. And I think there's not a lot of clarity in terms of like what true AOI is, or maybe the different types of AOI, or you could even argue that none of it should be called AOI, and it should be more of like machine vision or microscopy or different types.
I mean, what do all those terms actually mean? Because they kind of all sound the same, but I know that you are actually very semantically accurate when you talk about them. Could you maybe like bring us into the ABCs of AOI and computer vision and machine vision?
Yeah, I'd love to. So, okay, so what, I actually have like some visuals. I don't know if do we want to look at those? Okay, great. Okay, so let's do this. I'm going to present here. And can you see can you see it?
Yep.
Great. Okay. So AOI, love this misconception. It's kind of like a catch-all term. It's inspection cameras and software, right? Well, not exactly. So true AOI is automated optical inspection. So if we look at Wikipedia, it is a automated visual inspection tool for PCBs, for printed circuit boards. And specifically, it looks like this. So the true actual AOI machine is meant as a high volume PCB inspection machine, where it looks for the placement of components, which you see here on a PCB board, and looks to measure tolerances, size, component shapes. But that's it. That's what it is, and that's all it does. The reason this is important is because when we say AI, could mean a ton of different things. And what do I mean by that? And I think about like the industry, just to give you an example set, but a lot of people consider all of this AOI. So we're talking about inline, machine computer vision, We're talking about digital microscopes to look at like resistors or wire bonds. We're talking about optical comparators to inspect and measure consistently, and interferometers and laser confocals to take like coatings and 3D measurement and all of this. So in essence, everything on here has a camera lens, a camera, and some kind of stage, but all of these play in the space very, very differently, and they serve a multitude of purposes. So I've wanted to bring this to the table. Love talking about this, and I think depending on what is where they play depends on what the primary competency that you need them for. And so if you think about kind of like whether we're in an R&D or prototyping lab, line, whether we're in a manufacturing factory, you're going to use various types of different technology for various different needs. And so this is sort of like what I wanted to present today, and this is kind of how it fits in there. And what I mean by this is, like, for instance, if you're looking to discover and characterize, maybe you're early in your process, you just want to see what things look like, you want to know what the measurement is, but you're not trying to consistently measure. So you might use digital microscopes or laser confocal. If you're in a development phase where you are, you're really more trying to you look for discovery, look for clarification, you're kind of validating your processes, you're going to more like maybe measurement AOI type equipment. And in a production use case, where you're really just verifying tolerance. Is this thing in spec or not? And parts are through there. You're going to use more traditional type Y or machine vision. These kind of in the field differently, but there's synergy between all kind of different realms, and there's not really clear dividing lines. And this is where it gets sticky, because a great just to be honest with you, like a great or a talented salesperson can make any tool sing and like really show its, flair, but you need to just stick to like trying to discern what is a core competency of that tool, what I really need it to do. And just to kind of make this a little bit more black and white, like, am I looking for a tool to do mostly imaging, but also some measurement? Do I need a tool to do mostly measurement, but some imaging? Or am I looking for just a pass-fail judgment? And maybe that's a combination of imaging and measurement. So you kind of see when I play with these words, they all sort of, play in that space a little differently, but they all sound the same. And so that's why it's really important to get this right and to get it right the first time. And so that's kind of like why we're here today. And we can kind of dive into this, but I mean, I think, again, when you look at the reason that these things fail, people aren't always realistic with their, here, maybe I could share this for just a second longer, but people aren't always realistic with, did they buy for that core competency, or did they see a cool feature?
What does that mean? Like, give us an example from your,
yeah,
from either, a customer who might have made a mistake in buying the wrong thing.
Yeah, totally. So this is a great example. So on the right, this is kind of like we talk about, like, people are like, oh, I need to measure stuff. And the measurement's such a loose word, like all these words are loose, but like some imaging technology is primarily used for measurement. And what that means is it's very repeated. It's highly precise. And so if we look at like an archer shooting arrows at a target, right? In manufacturing and higher volume lines, you care more about this, because you just want to know that all the arrows will hit in the same spot, and you can actually recalibrate. You can just adjust your sights, recalibrate, and they're going to hit, roughly in the right tolerance. And all you really want to know is not what that tolerance is, but is it out of spec? Versus in the R&D realm, when I'm trying to characterize something, when I want to check look at the characterization of a thin film on the surface of a solar panel, or maybe I'm looking for like a size of a via, and I just want to take a measurement. I just want to know that it's roughly, but I'm going to take a lot of various different types of measurement, and not at all at the same frequency. So this might be more of like, just to give you kind of an example, of like you know, you care more about that accuracy, like how small the thing can I see versus how reproducible is it. And I think that you know, you kind of have to sort of decide where you want to play because nothing does everything. And you know, and I've seen these kind of like when expectations don't stay realistic, um, people also think that technology is going to be a magic wand to just do everything. Like I'm going to buy this thing, it's going to do everything I ever want. And when you get in the machine vision world, I remember a long time ago with a cell phone customer that we had, and they wanted to look at like a button. And then a few weeks later, as the project progressed, they're like, well, can I look at the button and the letter in the button? And then, oh, I also want to monitor this failure mode and this failure mode. And every time they add another kind of expectation on it, an expectation, you know, nothing does everything. And so what happens is you try to like, you know, you have to prioritize what your needs are, what your core competency is.
Well, I think like many people who are looking for machine vision solutions don't know the total scope of everything they're going to need because they're usually like early on in a program. And so scope creep seems like it's kind of a fact of the situation. I guess what advice would you give to people who you know would like to use more vision? Because certainly like even an instrumental, we don't really view ourselves as an inspection or AOI or vision company, but we occasionally do talk to customers that are interested in those solutions. Like what is the advice around like how they should go and find like who's going to be the right vendor for them, whether it's going to be a good fit? How do they get their expectations aligned with possibilities?
Yeah, great question. I think you need to one, prioritize again, like where do I lie? Like if we are looking at my little, you know, trifecta chart here, you know, what is the core focus of what I'm trying to do? And so I think like in terms
So like
of
focus on a particular stage and whether you're really like, is measurement really critical? Do you need to do the pass fail because it's like going to be in a production line? I think part of the challenge is that in actuality for manufacturing, you go through all of those stages and like it's unreasonable to buy a different device for each stage. Like it just feels unreasonable. Like I like bought this $50,000 microscope for my prototyping stage, and now it's not going to work for my development build stage, and then I'm going to need even another third thing for the production stage. And so I think many people try to get something that'll work for at least more than one of those pieces. Like what's your recommendation there? Like should people that are going out actually look for systems that will be good for production and then try to get benefit out of them in development? Like I remember working on the production line for the first generation Apple Watch. So it was the first time we had built it. There's a lot of vision systems on that line. And a lot of them didn't work very well as development pieces of equipment, but we were kind of dealing with them in development because we felt that we would need them for production for their pass fail capability once they were programmed in and tuned in. Like, is that the right approach? Is there a different approach that, you know, folks who are buying vision systems should think about, and maybe more efficient approach?
You know what's funny is there's a point where you were my customer too. So this is kind of a funny conversation.
I think there was literally like a camera on the back crystal that was like 2 megapixels. And we needed a rotation that was like plus or minus like 1 degree. And like, that was like literally less than a pixel at the resolution. And so there's like no way this was going to work. But yes.
Yeah. Well, I think, listen, I think, you know, yeah, and 100% but that's the kiss of death. That's exactly what we're talking about. And I think that, you know, I hear people all the time that are like, you know, we have this machine, doesn't really work that well. And like
another piece of a computer vision equipment that doesn't work well.
Yeah. Let me check. Can you see this here?
Yeah.
So a great example, let's just use this chart. I'm in development and I want to verify, you know, we are like a low volume, high mix, like right now stage, right? We're trying to iterate, we're trying to discover things, we're trying to to move, faster than we were during this R&D prototyping stage. And I'm trying to use a production piece of equipment, like a standard AOI machine, but we haven't figured out our solder, reflow process. And we're getting all of these types of different failure modes. Well, this machine is looking for specific failure modes because it's meant for like high volume, right? And when you are like verifying a tolerance, it's not meant to understand and clarify like more what you're measuring. So the end result basically is it's kind of like you're jamming a square peg in a round hole, and people end up the thing what happens is more production than in production, nothing's supposed to change. It's all about control, right? And so like, but in development, I think that people things do change. That's why that's literally the definition of developing a product is you're iterating and improving it. And I think when you use a tool that's meant for production in development, you end up trying to reprogram it. And in programming, there's hurdles with actually logging in, and you need to know what the failure modes you're going to see versus more discovery kind of like I'd say more discovery based tools which is in that fringe, but like on the measurement or on the microscope side might be better because you really are just trying to see what you see and then make a decision versus trying to set up this pass fail. And I see this, I've even seen it in medical before. I've seen microscopes get validated for things they shouldn't be because people are literally like on screen, like measuring a distance between something and clicking on a point to point. Never mind the fact that if you click on the diagonal, you're going to measure a longer distance. And I'm like, that's validated? Like
parallel at a distance, important feature.
Yeah, exactly. And so that's what I'm saying is like
so training matters a lot as well in terms of the value that you'll be able to get out of the system. I guess like what are like as a former design engineer who spoke to a bunch of like camera sales reps, they would they kind of all seem the same. Like you could get this Cognex system, you get a Kian system, all sorts of different versions, line laser versions, imaging systems, microscope systems. Like what's the deal? Like what do they not really tell you when you're buying one of those systems? Like I know one of the things that you've told me in conversation is like you're buying a bunch of parts in a box. Like you're not really buying a system. Maybe tell us a little bit about like what is required to take one of these systems and kind of put it into practice, and what should when our users, our community is out there like trying to figure out which vision system they should purchase, like what should they be thinking about in terms of additional costs and additional time that they need to put on top of that vision system to actually make it a solution for them?
Well, one is if you've never done it before, don't try it. I would say yourself the first time.
Like go with a systems integrator, or
yes,
like don't 100%. Buy.
Well,
or build your own.
I think you'll see some places. A lot of factories have in-house teams, people that are dedicated, that live and breathe machine vision. Some of them do, and those teams have experience with the programming, the setup. I could just give you like a little pro tip here, but when you look in a brochure and it looks like all the cameras are just floating in space, that means you've got to like fixture all the stuff and connect it all and set it up and do it yourself, or somebody's got to do that.
And that's hard, right? Because like, doesn't stuff like lighting matter a lot?
Yeah. So just to give you kind of like some examples, just to sort of share, this is sort of like, this is just an example, and this is what I mean by, you might have like a setup and there's different cameras that go to a controller that also connect to like a lighting controller. And so connecting these things, it needs to be done correctly. But this alone is just the beginning. Then just if we look at steps in the process of getting a camera, setting up a trigger sensor, illuminating, getting the lighting correct, capturing the image, running machine vision tools and processing, which we'll talk about. But when you get into, like there's like different types of interface and programming, there's complexity and complexity.
So that like, sorry, go back to the programming, like that looks hard. Who
It
does that?
is.
Does
Yeah.
does the sales rep do that? Do you need like an SI to do that? Like, how much does
So
that cost?
that's also a good that's a good discussion point because the sales rep usually it depends on the model. And so those are good questions to ask. I would verify is like, how long, what type of support I'm going to get with this. Um, I'll be honest with you. Part of it is buying the box of parts and understanding how they connect, and then the other half is getting it up and running, and then the other half that you don't even think about is debugging it. And typically the lead time on to walk through this, to understand the various types of different lighting, like what you need. I mean, this is just an illustration, but there's all types of different kinds to get the proper image and to get everything connected. Can add cost and time. The 4 camera setup itself might be 40 to 50,000, right? Or maybe let's say 30 to 50,000. Integration and setup time could be double that. And in the time lead time might be 2 weeks, but by the time you get it debugged, up and running, and actually running parts, and I'm sure all the factory guys know this here, and this is why they're all kind of the salty veterans, because they've been the ones stuck with configuring this stuff, is that could be another few months. So yes, and I think that's why you have to be realistic about what is your core competency, in terms of, like, do you have a support team in house? If you're going to buy from the vendor, what level of support are they going to provide? And just being realistic about what does that process look like? Because really people think the the process is the evaluation, the demo, the purchase, and then they don't think about, like, the back end is going to take maybe 2 to 3 times longer.
The implementation itself is as much a part of the project as figuring out which system to buy.
But the crazy thing is that's where it can live or die, is like in the back end, because and that's why I think everyone that's ever worked in a factory, that's ever worked on a line with a machine vision camera, has some horror story about how they had to go in there and constantly tweak it. And it's really because a lot of this stuff is meant to control based on a certain set of variables. Like, you're looking for a label or a bezel or whatever it is, and it needs to be in the same spot, and manufacturing is messy. And when things aren't in the same place, then you have to go back and reprogram it or add a certain layer, and it's missing stuff and you're not sure what it's missing. And so that's why I think, it's kind of the funny part about now is, like, people get PTSD when you talk to them. They're like, oh no, another machine vision. I mean, machine vision is almost like a religion. It's like, you've done it for long enough, you don't want to learn another one. Like, your mentor taught you this, you had to learn
It's
this.
like a loyalty program that's very strong. You fly
Yeah.
United, you always fly United. You fly Delta, you always fly Delta. You buy Cognex, you're only gonna buy Cognex. You buy Kians, you're Kians.
100%. And then
not like a lot of mixing of the different pieces. So for those who are working with systems integrators, like, I think part of the challenge there is that the costs, like, really add up in order to get something that's going to work. Do you have any recommendations for common, like, I guess, pitfalls in, like, buying systems through systems integrators, or any kind of advice for folks considering that?
I would I know I keep sounding like a broken record, but I would go back to the core competency of the person you're partnering with. So what I mean by that is, in the automation world, like, if someone specializes in pick and place machines, but you have a continuous motion line, like a bottle filling process, and that core competency of that system integrator or that machine builder is pick and place, they may not be the best partner. You might want to find someone that does more continuous motion type machines, or if they focus on more medical device. I mean, I think this is why it takes, why people spend a lot of time trying to pick the right factory too, is because they know, it kind of starts from the foundation blocks of, like, how that factory knows how to build those products. But part of them knowing how to build the products is knowing how to have the inspection equipment to get it up and running to do that. And I think that has to do a lot with, in system integrators and machine builders, and they're different. So you got to look at, like, what do they do well? Have they worked on similar parts as yours? you know, and I think that's kind of like the safe spot to play. But it's a tough, you know, I think it's challenging. There's a lot of different, again, it comes down to your process too, just being realistic about like what you need, in terms of like what, you know, what volume are you at? Where are you in the stage? Are you more of at like a early stage development, or are you fully ramped and you feel like you're in control? And you know, I think if you had a sloppy development, and there's still going to be a lot of debugging happening during your ramp phases, that might be something you want to kind of consider too. Yeah, I don't know.
Are there, maybe as kind of a parting question, is there anything that machine vision or computer vision or AOI is not good for, that like that people might think, oh, of course it's gonna be good for this, and like they really just should not buy a system if that's what they like, that just either the technology's not there, or like to get it actually working that way just really doesn't make sense. Like, you know, we talk to customers who customers who are interested in instrumental, or who probably actually should be talking to the machine vision people about cosmetics. Like, are there any systems that can find like a small black dot on an iPhone and on any surface? Like, is it just we haven't heard of it? Give us the details and the scoop. Like,
well, I think
where are the limitations?
Yeah. I mean, I think that's a good question. I think if you don't, like, if you're using a machine vision solution to help you discover new events, like to try to discover, like to understand like new things, or find new stuff, that is the wrong intent. It is meant to control. It is meant to control and monitor, and that is it. And what happens
So
is
only known issues, only
yes,
things that have rules,
known
rules that you can wrap around, like thing
Yep.
is here or not here, thing is at this distance, or, you know, between these two distances, but not like amorphous things that don't have rules.
Yep, and that's where, I mean, if you look again, like what we're just as even at this illustration, like, you know, we're looking at this filament element here, they're highlighting this for a specific reason. That's kind of the ironic thing, is it's a camera in software, but it's not looking at the entire image like a human eyeball would. It's looking for specific measurement, specific tolerance, maybe a distance, and very within a known field. And that's where, when you get in, that's why everyone says like the holy grail is cosmetic inspection, because it's like it happens everywhere. You know what I mean? Unless it's like a bad fixture design, where it's scratching on a certain spot every time. Those things are just really challenging to inspect for. And so I think you got to be realistic about, if you're looking to control it, then control it. Then I think machine vision will work well. And if you know the failure modes, and you know, have some kind of idea, I think you're in the right space. But you know, I think flexibility is not in the same equation as you know, machine vision inspection. It's not meant, but it's not meant for that. That's why you have other tools.
And if you want to discover stuff, what do you do then?
You know, without I'm not supposed to do any selling here, so I'm going to say, like, I think looking for, but I think that's where the AI tools are opening up that area. You know, trying to provide more of a discover tool. I think that's what's exciting a little bit about what we're doing, is adding complementing that machine vision, adding a layer on there where you can look to help discover. There's not really a great way, because, you know, honestly, I think that exists right now. Aside, and that's why what our mission is pretty fun, you know, exciting about.
Well, it exists here at Instrumental. It just doesn't exist. It's in terms of issue discovery, but to your point, the cosmetic inspection remains a challenge for all of the different techniques and technologies in machine vision. There are certain use cases that have been collapsed enough that you can do cosmetic inspection on. Like, I know you can like look through a piece of glass and look for scratches by using like light to be able to identify scratches if you're looking through a piece of glass.
Or polarization.
Yeah, and you can certainly look at like certain regions and find things in certain regions. There's some pretty awesome looking demos of some of the AI products like that Cognex has that like could find a defect and like track it in a video of like a spinning piece. So it does seem like there's like maybe stuff coming, but we haven't really seen that yet in the market.
But the other thing I would watch out for too is not to get sold on demos, because there's a lot of lab, like I call them like lab-based solutions that are out there that it doesn't commercial, but you know, if you test it with your data, see what it looks like, and like see, does it find new stuff? Does it help you find things you didn't know were there? If you have to put in a million, you know, or not a million, but hundreds of thousands of different like inputs to have an AI engine that becomes like functional, like I don't know, I think that's kind of flawed thinking as well too, because I just feel like that like who has time to do that? Then you know what I mean? Then you're kind of like spending just as much time debugging it as like the traditional machine vision issues.
And so now, as we wrap up here, now, you know, handcuffs off, you don't have to worry about not selling, but like answer the question that many of our customers have, which is, how is instrumental the same or different from AOI, machine vision, computer vision?
I think that what we're doing, which is pretty exciting, is we are tying in the gaps and helping. So there's a couple things we're doing. I think if we look at this again, this kind of like primary competency sort of split, I think we are helping people in each of these stages. And I think we're tying in, you know, in the discovery and characterization, people are doing more images. They're having like their hard drives are backing up. They're having like tons and tons of data collection. The microscopes are becoming automated. So we're helping sort through that data more rapidly to find, you know, anomalies and help them find the most important things that matter. I think in the development period, we're providing a discovery tool and clarification on where the issues lie. And then I think at the same time, in a production use case, we're helping them learn where their issues are and then validate and verify the tolerances, you know, in the background. And I think we complement all of these tools. And that's the beauty of what we're doing, is it doesn't matter. If you got a picture, you know, we want to have part in it. And we'll help find you know, discover new issues, monitor those lines, and solve those problems throughout that entire process.
Awesome. Great. Well, thanks, Alex, for being a first guest on Change Notice. And thanks to everybody who attended. If there's any questions